Good morning, this is Russell Smith with Computer Science 2100. I'm going to be doing problem set 2, problem 3. Just like in problem 1 and problem 2, we're going to be trying to find a minimum monthly payment for a balance of $5,000 and credit card interest rate of 18%. But we're going to do it a lot more accurately with upper and lower bounds, and I'll explain that as I go through it. But first, we need the function to do all this. What we're going to be doing is finding the minimum payment, so I'm going to call it that. We're going to be using two variables. Spell interest wrong again. So just like before in the other problems, we have an annual interest rate and we need it to be in monthly interest rate. So to get that, we're going to divide the annual by 12. And it looked like it auto-populated good, so I'm going to use that. Okay, so here's where the lower and upper bound concept comes from. Lower bound is if you had no interest rate compounding monthly, how much would you have to pay each month to the $5,000 balance to pay it off? So to find that, we're going to divide the balance by 12 to pay it off in 12 months. And then the upper bound would be the absolute most you'd have to pay considering the interest that compounds monthly. So, and it auto-populated there, but I'm going to go ahead and just type it out so I can explain my logic behind it. So we got the balance, which is 5,000. It will be. I hadn't set the balance yet, but multiply that times the interest rate raised 12 times. So raise to the power of 12. Or, yeah. And that's going to be the absolute most that you'd have to pay. So the upper bound of the payments. So that's the absolute most, the upper bound of the payments, and we're going to have to divide that by 12 because that's done for the whole entire balance. But we're doing it over a month, over 12 months. Then I'm going to call this epsilon. In the research I've done on this because I did have to do a lot of research. I saw that it was typical to call the accuracy epsilon, so I'm going to stick to that. And that's what we're going to use in our loop in a little bit to determine if we're accurate enough for our monthly payment. And we want it accurate down to the cent. So let's start our loop now. Well, upper bound, get it auto-populated for me. If it's greater than a cent, that means we're not accurate enough yet. So that's why upper bound minus lower bound is greater than epsilon being a cent would mean that the loop needs to continue. So I'm just going to go ahead and type that and have it auto-populate. So now we need to calculate the midpoint. between the upper and lower bounds, which will be the guessing, the start of the guess for the loop. So to do that, it looks like it auto-populated the first one good, but I'm going to type it out because I don't like the second part there. So I'm going to say it needs to be 2, not 12. So now we need a line to initialize the remaining balance to be the original balance from the start of each iteration of the loop. So so now we need another loop that does it for each month of the year. And now we need a couple lines to update the remaining balance for each month. So these are the 2 lines are updated the remaining balance for each month. The first line subtracts the monthly payment from the remaining balance, and then the second line adds the interest rate to the month to the remaining balance. That's not right. That needs to be an addition. Oops, I don't want all that. It might be right, but I'm going to type it out. So now we need a couple, or some code that checks if the remaining balance is positive or negative after 12 months, and then I'll explain it as a type. So, and if remaining So this checks if the remaining balance is greater than 0, and if that's the case, then the lower bound is set to monthly payment, meaning that we're close. It might not be right yet, but we're close. At least we didn't go negative, because if else, then the upper payment, the upper bound, whatever we have it set at in this iteration of the loop, is going to be considered the monthly payment. Then, when everything's good to go, we're going to return the monthly payment, but we're going to round it to 2 decimal places because we're doing it to the nearest cent. And that should be good for our function. Now we're going to define our values to plug into the function. So we're starting with $5,000, the annual interest rate of 18%, if I can spell it right. And we need to run the function using those values. It's going to use the balance and the annual interest rate. So now that we've found the minimal payment, we can print it. Turn it into a string since it's an integer. Misspelled. I'm just looking it over to make sure I didn't misspell anything else. Looks good. Let's see what happens. I did misspell something. There you go. So this is using a function that uses the upper and lower bounds of a payment to accurately figure out what the minimum payment should be for a credit card balance of $5,000 with an annual interest rate of 18%. It's more efficient doing it this way because it's using less loops in the loops. So this has been Russell Smith with a Computer Science 2100. Thanks for watching me code.